Okay, so in this exercise, we are going to find a number of hosts instead of number of network that we performed in the exercise number one. So before do anything, just go through this case study, which is saying you are an IT administrator for the organization. Your boss head over to you and told you that our previous network working fine, but when we added more hosts to that network, they were basically unable to communicate with each other. Okay, he wants you to take a responsibility to find out a better solution. So what basically it's trying to say, in the last exercise, we find out the number of networks. Okay, but we were not concerned about the number of hosts that exist on that network. Okay, let's suppose we find out some network range which was like 216.21.50.0, and with the subnet mask that we have already identified. I think that was slash 27, something like that. So this is one network, but how many hosts it can accommodate? So let's assume that it can accommodate only 20 hosts. It means only 20 computers I can assign this range. But what if we are going to increase, or we are going to add another computer? But since we are only restricted to 20 hosts, when we will add the 21st host, this will not be able to communicate with this either of the PCs, because that is now on a different network. So what is the solution? Solution is, instead of finding in the perspective of network numbers, we are going to find a number of hosts. Okay, so the requirements are same like class C. This is the IP address, and the number of hosts we want to find are 40. So let's head over to the next slide. This is the same, you might be familiar with the same card that we used in the earlier exercise, but I made some changes there. I just wrote some comments to make you understand what is it for. But right now I'm sure you might be familiar what this one is being used for and what this one is being used for. Okay, so very quickly just copy this one and take this to the MS Paint so we can perform our action here. So this is the requirement. Uh, this is the IP address. This is the IP address. This is from class C, and we know the class C is having subnet mask is /24, or in other words, 255.255.255.0 subnet mask. How many number of hosts we have to find? 40. And one thing, I told you, when finding number of networks, we usually steal bit from left to right. Left to right. But when we have to find number of hosts, we will move from right to left. Okay, in order to steal bits. And when I will perform, you will see. Okay, so just we need to fill out these blanks, or these the criterias: number of networks, not networks, number of hosts, are 40. Bits need to steal. How we can find bits need to steal? We need to compare this with this base system, and where this base system get um, become larger than uh, the number of hosts in question, we will stop there and then we will count at what position our criteria matched. So let's do it. The criteria is base to number system is greater than 40. No. Is 4 greater than 40? No. Is 8 greater than 40? No. Is 16 greater than 40? No. Is 32 greater than 40? No. Is 64 greater than 40? Yes. So our criteria matched at this position. So we have to find or the count the number at what position this our criteria matched. So 1, 2, 3, 4, 5, 6. So we need to write down 6 here. Okay. After that, and by the way, one thing I just want to apologize. In my last or in the first exercise, I was saying something and writing something. I was saying is 2 greater than uh, that the information was that in the first exercise was, let's say, 30. Okay, so I was doing like this, so that was wrong. So this is the right method. So things that I am missing in my exercise number 1, I'm going to fulfill in this exercise number 2. After that, we need to convert decimal into binary. For that, instead of doing that conversion here, you already familiar how to do decimal into binary. So very quickly I will go to the that IP binary converter calculator, and I will put this IP address 216.2.216.21.50.0 and then convert into binary. So just copy this format and put it here. Okay, so the task that we have already achieved, we have the number of host, bit need to steal 6, convert decimal into binary. After that, we have to find or determine the least significant bit. So how many bits we need to steal? 6. And I told you when finding host, we have to move from right to left. So we will move right to left. 1, 2, 3, 4, 5, 6. So we need to draw a line here. Okay. Then we have to determine the least significant bit. So this is your LSB. But we have to find out at what position this least significant bit is sitting. You can again correlate with your base 2 numbering system, like this bit, this last bit is at this position, this one is at this position, this one is at 4th position, and this 4th bit is at 8th, then this 5th one is at 16, 6th one is at 32, and then the least significant bit which we are looking for is at 64. So this is going to be our block size, 64. Okay, and this also we have performed. So we have already determined the least significant bit and its position, and then we have written down the block size, which is 64. After that, we have to determine the subnet mask. We know the class C default subnet mask is 24. But what is the new subnet mask after stealing the bits, which we have to calculate? 8 for this octet, 8 for this, 8 for this, and then how many bits are remaining are 2 plus 2. So just add these all, 8 plus 8 plus 8, 24, and add 2, 26. So it is slash 26 bit notation. So instead of 24, our new range is slash 26. Okay. After that, we have to determine the range. So we will perform the same step that we have done in the exercise number 1. We know the block size. Now, the first IP address is 216. So I'm going to use, let's use brown color for that. The first network ID is 216.21.50.0. The second network ID will be what? This 0 plus the block size, 216.21.50.64. And the third network ID will be 64 add into the block size, 216.21.50.64 plus 64, 128. Okay, so we got the ranges of network ID for 3 networks. Similarly, we have to find out the broadcast ID as well. And how broadcast ID we can make? Just by adding 1 into the network ID. Sorry, not adding 1 into that is the first host ID. To make the broadcast ID, we have to determine what is the second network ID minus 1. So do it, 216.21.50.64 minus 1, 63. And for the second network, we have the broadcast ID is 216.21.50.128 minus 1, which becomes what? 127. So these are the network ID and broadcast ID. The other thing we have to find out what? The host ranges. The actual host is that really we will put as an IP address on our host machines like laptop, Android devices, printers, routers. Okay, so let's find out those ranges. For that, I'm going to use this maroon color. Okay, I have already mentioned whatever comes in between network ID and broadcast ID are the host ID ranges. So the first host ID you can get just by adding 1 or into network ID, which becomes what? 216.21.50.1. And similarly, the last host ID we can get from the broadcast ID minus 1, 216.21.50.62, 63 minus 1. Similarly, for the second network ID, 216.21.50, adding 1 into this range 64, which is 60, means 64 plus 1, 65. And the last Host ID will be 127 minus 1, 216.21.50.126. Okay, now we need to actually verify whether what we have done is okay or no. For that, I told you we need to go into that IP subnet calculator and open from this hyperlink. We know that exercise number 2 is from class C. The IP address is, I just want to correlate, 216.216.21.50.0 and the subnet mask. So before I show you subnet mask, I just want to show you how we can uh, create the subnet mask, because we have in bit notation. This notation is slash 26, but we actually have to convert this into the decimal format, because when you have to provide the IP to any machine, how you are going to provide the IP is, let's say, pick from this range 216.21.50.1. Then what is going to be the subnet mask? You have no idea. Okay, but you have to find out how. I'm going to show you. First of all, I will copy this same uh, you know uh, same format that I used it, because now it has become a mess. That is why I'm going to use the new copy of that binary. Okay, and put somewhere here. We know that uh, we stole the bits until here. Okay, and we know that this is, if you add if these all these all you are going to convert into what? Ones. Okay, just again copy this one, because this is your subnet mask. So that's why you do not care about these bits. So convert this all into 111. 1 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And then from host portion, until you have stolen the bits, you need to convert into ones. But since these have not stolen, you will keep those bits as it is, like zeros. Okay, so from here, if you add these all ones into decimal, it become 255. If you add these all values, it become 255. If you add all these value, it become 255. And if you add these two values, and we, from now on to onward, we know from our experience these two bits exist here at these position 128 and 64. So we have to add these two bits, 128 plus 64, which becomes what? 192. So this last portion will be 192, and this is how our subnet mask will be look like. So we need to put that here, 255.255.255.192. Okay, so we have to verify this as well. So first of all, let's go here, and we know that that was our slash 26 subnet mask bit notation. So we have to find out here 26, select, and this was the IP address, and that is from the class C. So click on the calculate. First we have to verify the subnet mask. Are we in compliance with the subnet mask that we have already calculated? So go here and just match it with this one. As you can see, the subnet mask match 255.255.255.192. Then we have to find out the ranges. Just take a print, just copy to clipboard, and then we need to come here, and then we need to verify. Okay, they went all the way to the fourth network, but since we are not looking for networks, we are looking for the host, and I will show you from where you can see the host. So first verify this one. We can see a 50.0 match and 50.64 match, so network portion is looks okay. Then we have broadcast 63 and 127, 63 and 127, so this also matched. So these are the host ranges which we find out here. 50.1 all the way to 50.62, 50.1 all the way to 50.62, and then 50.65 all the way to 50.126. So it matched. So it means whatever the objective or the task we want to achieve, we have achieved. Okay. So number of hosts, how many require? 40 or even more than 40, because that was the requirement. It could not be exact 40 range. If I will take you to the subnet calculator, and if I can show you the number of hosts are 64, or the usable hosts are 62, it means this is 62 is greater than 40. So this is what we were looking for. We were looking for a number of hosts 40 or even more than 40. Okay, so the final piece of information, or the task that I would like to perform here is I will just pick one IP address, and then we'll connect two computers, and then I will basically will provide two IP address, and we'll try to ping from the same range. Okay, so for that, let's make a new uh, this drawing board for us, the new landing page. So click no. Now we need to bring two computers, PC1 and PC2, and from here just zoom it in and connect these two PC with the help of Ethernet cable. So if you are not familiar with the Cisco packet tracer, don't worry. In our the subsequent sessions, I will be covering Cisco packet tracer a lot in detail, because most of our labs will be performed on Cisco packet tracer. After that, let's pick a range from this host ID. But before I provide this IP, I just want to show you one thing. If you will, I told you the network ID and the broadcast ID, you cannot put this IP. Okay, this is invalid IP. Let's suppose if I do it, if I go to the desktop IP configuration, and I will try to use this one, 216.21.50.0. If I will do tab, you can see it is an invalid IP for this subnet mask entered. So your computer is intelligent enough. It knows that uh, this is the network ID. You cannot use this one. So if you use the IP from this range, so let's do it. 216.21.50.1. The default subnet mask is 255.255.255.0, which I have mentioned here. But we have created our own customized subnet mask. So we have to provide that one, 255.255.255.192, and hit enter. And you can see this is a valid IP and subnet mask. So same, the next one is 50.2. I'm going to provide on the another machine. So go desktop, IP configuration, put the IP with 50.2, and the subnet mask will be this one, 255.255.255.192. Okay, that's it. Now let's ping one PC. uh, so let's ping from one PC to another PC. So I will keep here. Okay, so I am going to ping this PC basically with 50.2 IP, 21 sorry, ping 216.21.50.2 and hit enter. And as you can see, the ping is successful. It means this computer or host machine can ping to this host machine. So let's try another thing. For this PC, I have assigned the IP from this range, but for the second PC, I am going to assign the IP from the second network range. And just to verify and to show you that these two, although looks same IPs, but they are totally on a different network. So let's go to the PC0, and let's change the IP here. So I'm going to assign 216.21.50.65, this one, and with the same subnet mask. Now I will try to ping this IP from another machine, which is this one. So let's go to the command prompt and try to ping this IP which is on a different network. So try to ping. As you can see, the pinging is being failure. Request timed out. Request timed out. It means that, which shows and verifies that this range is totally different than this range. So this is the same concept, like this is different street and this one is a different street. And we know that these two streets cannot communicate with each other, or these two different networks cannot communicate with each other. Okay, so I hope you get the idea. So let's head over to the next slide and let's see what we have there for us. Demo time, reverse